Hello friends, myself Nisha Vasudeva in Department of Computer Science, Engineering and Information Technology from Arya College of Engineering and IT. Today we are discuss designing of Turing machine in theory of computation. For the designing of Turing machine, there are two steps are present. Number one, the fundamental objective in scanning a symbol by the read-write head is to know what to do in the future. The machine must remember the past symbol scanned. The Turing machine can remember this by going to the next unique state. Number two is the number of states must be minimized. This can be achieved by changing the states only when there is a change in the written symbol or when there is a change in the moment of read-write head. We shall explain this designing by the simple example. In this step, we are studying when any of the state read any of the input value, we move to the next state with the replacement value. We change the state only when there is a change in the input value. If the input value is same, then we can not change the state or any replacement value, so we can minimize this step. In the next slide, we can see by the example. In this example, L, that is the language is given, that is 0 power n, 1 power n, and n is greater than equals to n. So first we select for some input, for some n value, we choose the string. That is, if we choose, in this example, we choose a string, it is 0, 0, 0, 1, 1, 1, that is the value of n is equals to 3. First we place this into the input tape. In this input tape, as we see, there is a B is also present, that is a blank symbol that is on the left hand side and on the right hand side. Then first we start from the 0, that is the first or initial symbol. First, any state read the value 0. The 0 is replaced by x. Again move in the right direction. On the right direction, again 0 is present. This 0 does not replace with any value. This 0 is replaced by 0 value and move on the right direction. Again 0 is present. This 0 is replaced by 0 value and move on the right direction. On the right direction, we can see 1 is present. This 1 is that is the different input value. That means first 0 is present, then 1 is present. First 1 0 is replaced, again first 1 is replaced, then second 0 is replaced, second 1 is replaced. That can see in this example. This 1 is replaced by y and move in the left direction. On the left direction, there is a 0 is present, then again it move on the left direction. On the left direction, again 0 is present, move on the left direction, x is present. Then we process, we can do this process. This x is replaced by x and move on the right direction. On the right direction, 0 is present, this 0 is replaced by x, move on the right direction. On the right direction, 0 is present, then 0 is replaced by 0, move on the right direction. Here is y is present, this y is replaced by y, move on the right direction. Again second 1 is find out, this 1 is replaced by y value and move on the left direction. On the left direction, we can see y is present, this y is replaced by y and again move on the left direction. On the left direction, 0 is present, this 0 is replaced by 0, move on the left direction. Again x is present, move on the left direction. On the left side, first x is present, then again we start this process. This x is replaced by x, second x is also replaced by x. Now we reach at the third 0, then third 0 is processed and this 0 is replaced by x value. Then next y, that y is replaced by y, then again move on the right direction. Next second y is replaced by y, then move at the third 1, that is the last one. This 1 is replaced by y. That means all the input values 0 and 1 that are replaced by some replacement symbol, that is x and y. Then we reach at next movement of the right direction, that there is a blank value is present. That means whole string is processed. First we process 0 value, then we process first 1 value, then we process second 0, then we process second ones, next we process third 0 and third 1. That means whole string is processed. This is replaced by some input value and we reach at the final state and the last blank symbol. That means this string is accepted. This is the designing of the Turing machine. We can see also the diagram for this. The Turing machine for the 0 power n, 1 power n, n is greater than equals to n. We can make the diagram for this. In this diagram, as we already discussed, we can represent by the diagram. Mark next, when q0 read the 0 value, this 0 is replaced by x, move on the right direction and the state is q1. Same q1 read the value 0, 0 is replaced by 0, and the right direction same y, and we can make the diagram for this. We can also write the steps for this also. In this step we can see this first step is mark next unread 0 with x and move right. Second step is move to the right all the way the first unread 1 and mark it with y or replace with y. Move back to the left all the way to the last mark x and then move one position to the right. If the next position is 0, then go to the step 1, else move all the way to the right to ensure that no excess once. If not, move right to the next blank symbol and stop the process, and this is accepted. That's meant we reach at the final state and the blank symbol. This is the Turing machine, or this is the transition diagram for this Turing machine, and this is the transition table for this. We can make a transition table from the transition diagram for this. We can represent by this. Here are the input symbols 0, 1 and b are present, and we can we take the replacement symbol, that is x and y. So according to these 5 value, these are the input tape value, and we make the transition table for this. Same for this, there is a next example for this. Design a Turing machine to recognize all the string consisting of an even number of ones. So we have to design any of the string of even number of ones, and we have given only the input string 1. So we can make any of the even number string, that is 1 1 1 1 1 1. As we see 2 4 6 8, these are the even numbers, so we can design for this. So solution of this is, the construction is made by defining move in the following manner. Number 1 is q1 is the initial state, and when q1 read any of the input value, it enters the next state on scanning on any of the symbol and replace with any input value, and write b. In the second step, if the m is in the state q2 and scan 1, it enter q1 and write b. Number 3 is q1 is only the accepting state, so m accept a string if it exhausts all the input value and finally is in the state q1. We can represent by this. Here delta is the transition function, we can represent in the transition table. When q1 read the value 1 and q2 read the value 1, there is only one input value 1 is present, and this is replaced by some value. We can choose minimum number of state with the minimum number of input value, as already described in the steps for designing. Let us obtain the computation sequence of this. When q1 read 1, then it q move to the right direction, and q1 is replaced by q2 and 1 is replaced by b. So we can write b q2 1. When q2 read again 1, this 1 is replaced by b and move on the right direction, and q2 is replaced by q1. So we are using here two state, q1 and q2. Here q1 is the accepting state. So we can describe any of the string for this. If we choose the string of the odd length, like 1 1 1 1 1 3 5 7, so this is not accepted by this automata, because this automata is only for the even number of string also. We can see of the other example for this, like design a Turing machine over 1 comma b, which can compute a concatenation function over summation is equals to 1 if a pair of words w1 and w2 is the input and the output has to be w1 w2. So we are given only the input value 1. We have to make the two string for this w1 and w2, then we have to find the output for this, that is the w1 w2, that is a concatenation of this. So we choose any of the string for this. So solution is, let us assume there are the two words w1 and w2. We can choose w1 is equals to 1 1, w2 is equals to 1 1 1. Then the concatenation function is w1 w2. That means the final answer we get, that is 1 1 1 1 1. That is the final answer for this. So in this diagram we can define this. This is the concatenation of two string, as the first diagram, that is b11 b111 b. That means we can combine two input string using the blank symbol, and we have to find the final answer for this. We have observed that there are the main task, that is to remove the symbol b, because b is the extra symbol, or we can say that if we find the output for this, if this b is replaced by 1, we get the 5 times 1, that is the final answer for this. And this can be done in the following manner: by separating the symbol B is found and replaced by 1. Number 2 is the rightmost 1 is found and replaced by a blank symbol B. And the number 3 is the read write head return to the starting position. That means in this diagram, as we see, there are 1 1 B, 1 1 1 B is present, and we have to find only the string of 5 length, that is 1 1 1 1 1. There is a one extra value is present. If this one is replaced by B, then we can find the final answer for this. So we can see this competition for this. When q naught, that is the initial state, this q naught reads the value 1, this 1 is replaced by 1, and q naught replaced by q naught, move on the right direction. Again q naught read the value 1, move 1 is replaced by 1, move on the right direction, and q naught is replaced by q naught. Then q naught read the symbol B, that is the different symbol. If we read the only one value, then state remains same, we are not changing any of the state. But when q naught read any different input value, then state is changed. As we see in this, when q naught read the symbol B, that is a different input value, this q naught is replaced by q1 and B is replaced by 1, and move in the right direction. Then next q1 read the symbol 1, again same, q1 remains same, 1 remain 1, and move on the right direction. Next again q1 read the value 1, this 1 remains 1, and q1 move on the right direction. And on the last one, when q1 read the last one value, this one is replaced by B to get the final answer for this, because we have to find the 5 times 1 also. So in this computation diagram, we can see we can find the 5 times 1, that is a concatenation of 2 input string. We can make the transition table for this uh, by this computation of this, as we see in this example. If we have choose any of the string that is 1 or 1, we can also concatenate this, like w1 is equals to 1, w2 is equals to 1, then we can find 1 1, that is the final answer. And we can start from the initial states read some input value, again we can replace by some another state with the replacement symbol and in the direction also.